Today we're in section 3.4, factoring expressions, okay, and it's still going along the same concept of like terms. I'm finding terms that an expression would have in common, okay, and I'm going to do something with that. All right, so that's really a lot of what today's lesson is about. All right, you need to know a couple terms. GCF. GCF is a major part of today's lesson, but it's like what you are expected to already know to do the work that we're about to do. Like GCF has to be more or less automatic at this point, okay? So we're going to review GCF, but this is not a lesson on GCF. It's a lesson on factoring, all right? Factoring expressions means to pull out the common factors between the terms, which is, after all, what GCF is, right? The greatest common factor. So we're looking at the biggest number that goes into both numbers. Let's take 28 and 40. Okay? I'm not going to give you crazy big numbers like 320 and 460. I'm not going to do it, okay? They're going to be, for the most part, basic numbers because, again, I'm not testing you on GCF. It's a factoring lesson, okay? But we've got to be able to find GCF pretty quick. And this is the quickest way that I know how. All right? It's not possible for a factor of a number to be larger than that number. Right? That goes against the definition of a factor. A factor has to be able to go into a number. Right? So what I'm saying is it's impossible for my GCF to be more than 28. So I always look at the smaller of the two numbers. Okay, you with me? And what I'm going to do real quick is I'm going to write down the numbers that can be multiplied together to equal that number until they repeat. So for 28, and we're not even going to, well, we can do 1. No, we're not going to do 1. Yeah, we'll do 1. 1 times 28. Is there a 2? 2 times what? 14. 14. Is there a 3? Nope. Is there a 4? Yes. 4 times 7? Is there a 5? Is there a 6? Is there a 7? Yes. But that repeats. So as soon as it repeats, I know that I have all the factors that are possible. So now I go back to my largest number. Does 28 go into 40? No. So even though it's a factor of 28, it's not a factor of 40, so therefore not GCF. Everybody agree? Yep. Okay. What about 14? Nope. What about 7? Nope. What about 4? Yep. Yes. So that's my GCF. Now, that took us about a minute, okay? When you're doing it, it's a matter of seconds, okay? So it really is a quick way to find GCF just to make sure, because guys, if you don't find the GCF, your factoring will be wrong, okay? So the GCF is really important that we're sure that we found GCF. Again, the numbers aren't going to be huge, but we can list factors to find the GCF pretty quick, all right? Is everybody clear on? You can do upside down division. Did y'all use upside down division last year? Yes. Okay, the upside down, you divide by prime numbers. Yes. Okay, you can use factor trees. It's just going to take you forever. And listing factors is the fastest way, especially when our numbers are small. All right, so let's look at example 1. Okay, which number out of 28x and negative 18, we're just looking at coefficients, the numbers, which number is smaller? 18. So just off to the side, okay? Well, again, does 18 go into 28? Well, that would have been nice, but does it? No. No, so 18 is not GCF, so let's go to 2. 2 times 9 is 18, correct? Yes. Any other numbers multiplied together to be 18? Yes. 3 times 3. 3 times 6, but nothing else, right? Right. Okay, so now we start at the biggest number. Does 9 go into 28? No. Does 6? No. Does 3? Yes. No. I know. 27, but not 28. So 2 is my GCF. All right, so as soon as you can visually see the factors, it's usually pretty obvious which one's the GCF. And that took us about 30 seconds, okay? So what I'm saying by, kind of telling you what the time is, it's not extremely time consuming, but now I know for sure what the GCF was. If you had just looked at that expression and said GCF is 2, you might be second guessing yourself. Wait a second. Is GCF really 2 or is there a bigger number? And by the time you go through all of the rationale, you might as well have just written out the factors. okay? Because again, if you're wrong and you don't pick the GCF, your factoring is wrong, okay? So this is a surefire way to make sure that you get the GCF. So here's what I do. Now that I know what the GCF is, meaning this is the greatest number that goes into both terms. Everybody agree, 2 is a factor of 28 and 18. I'm going to pull it out of the expression. It's basically reverse distributive property. It's distributive property in reverse. You're going to see that real clear here in a second. Okay? And you're going to divide the original number by the number that you factored. What is 28 divided by 2? 14, and then don't forget your x. Okay? What is negative 18? You got to pay attention to that sign. Divided by 2. Negative 9. Now watch this. What's 2 times 14x? 28x. What's 2 times negative 9?
Negative 18.
Negative 18. Has anybody ever put something together and then taking it back apart and then put it back together again?
Yes.
Has anybody ever done that? That's what we're doing here to this expression. The expression started put together. I took it apart. That's called factoring. And then to double check my answer, I can put it back together again to make sure it's the same expression. I'm not solving anything. Okay? All I'm doing is factoring out the greatest common factor out of these expressions. Okay, how am I doing so far?
Good.
Don't give me a grade, okay? All right, I'm doing my best here, guys. All right, so let's look at this one. Let's establish the GCF. Now, I know that this one seems to be a little more clear. And guys, the more we practice these, sometimes you're not going to have to go through the steps of listing the factors. But let's go ahead and do that to kind of train ourselves to look for the largest number. All right, 1 times 4, guys. 4, so those are factors. Any other numbers? 2 times 2. And again, we start with the largest. Does 4 go into 20?
Yes.
So 4 is our GCF. Now, could you have looked at that one and probably known that without listing the factors?
Yes.
Okay. So here's my response again, and you've already heard me say this once or twice. This part of your work will not be counted off if you don't have it shown. I'm not going to count off for it. However, if you don't get the GCF right, your factoring will be wrong. So it's worth the extra effort, okay, the extra couple seconds it takes to make sure. So we pull out a 4. All right, I want you to try to write what's left inside the parentheses. Okay, again, I take the original number and divide it by the number I factored out. What's 4 divided by 4? 1. Why? Okay. What's negative 20 divided by 4?
Negative 5.
Negative 5. Okay. Now let's put it back together to double check. What's 4 times 1y? 4y. What's 4 times negative 5? Negative 20. Okay, so it puts back together and my signs are correct. So yesterday in y'all's quiz, and you probably saw a lot of -3s, okay, maybe on your papers. Your signs, guys, your signs, we got to work that out, okay? Overall average wasn't bad, but we're making a lot of mistakes on our signs, okay? Same thing is going to go for 3.4. Signs are really important. Okay, but of course, you know, what's a lesson without a fraction, right? Okay, it's not going to be whole numbers every single time. So what in the world? How do I factor out a fraction? Okay, so even I was like, okay, I need to remind myself. Okay, so it's not necessarily that it's an easy concept when you first look at it. All right, but I've got some tips that I'm hoping will be a little more helpful to help you figure it out. And here's my tip. All right, I put it right in here in the example. You think I did that for you. I did that to remind myself. I'm just kidding. Okay, factor out the smallest fraction. So which fraction is smaller, 1/2 or 3/2? 1/2, right? Half is less than 1. 3/2 is clearly greater than 1. If you're in doubt, convert them to decimals and see which one's smaller, okay, if you're in doubt. So 1/2 is clearly smaller. So here's what you do. You factor out the smallest fraction. You just said it was 1/2, so you factor out 1/2 out of the expression, okay? You factor out the smallest fraction, all right? And now, again, what is left? Here's where the division is very important. And you are welcome to use your calculators. What is 1/2 divided by, remember we're dividing 1/2. What's 1/2 divided by 1/2?
1.
Because you flipped that second fraction, remember? Because you're dividing.
Oh, 1 over 1.
Okay? You guys want me to show that to you visually? 1/2, guys, look up here. 1/2 divided by 1/2, that's a KFC. Keep, flip, change. Okay? So 1/2 divided by 1/2 is really 1/2 times 2 over 1. I'm only writing this to show you, okay? You could do this in your calculator. It cancels out to 1. Okay? 1/2 divided by 1/2 is 1. Do you see that? Okay? All right, so I'm still doing the same thing that I did with my whole numbers. I'm dividing the original number by the number that I factored out. Okay? So it's going to be 1x. You just said 1/2 divided by 1/2 is 1x. Okay? Now, what is 3/2 divided by 1/2? And don't think that you know the answer without at least double checking it. What is 3 over 2 divided by 1 over 2? Double check it. What's 3 over 2 divided by 1 over 2? Okay, what is it, guys?
1/3.
No.
3 on 3.
Put it in your calculator. 3 over 2. This is very important, okay? Divided by 1/2. Okay, 3 over 2 divided by 1/2 equals what? 3. Okay? It is not 1/3, guys. Yes, I did. Are you telling me I didn't flip it? Oh, okay, yeah. Yeah, you got to flip that second fraction. If you didn't flip it, that's why you got 1/3. Okay, so go ahead and try the second one now. I'm going to walk around. Go ahead and try the second one. Factor out the smallest fraction, then divide the original fraction by what you factored. That tells you what's left inside. Okay, guys, which is the smaller fraction?
3/4.
3/4 is smaller than 1. 3 over 2 is larger than 1. Okay? So 3/4 is the smaller fraction. That's what I pull out. Well, what's 3/4 divided by 3/4?
1.
Divide it. You flip the second fraction, it's going to be 1. So it's just going to be 1p. Okay? Now, what's negative 3 over 2 divided by 3/4? Well, what's a negative number divided by a positive number? Is it going to be positive or negative?
Negative.
Negative. So now just worry about the fractions. What's 3 over 2 divided by 3 over 4? 1/2.
Yeah.
Wait.
Yeah.
Wait, huh?
Let me double check it, but
Wait, I got the same answer. What? Did you say 3 over 4 is smaller than 3 over 2?
yeah.
I thought 3 over 4.
No, it's 2. 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 I read the problem wrong. It's 2. Okay, now I need to show you. 3 over 2 divided by 3 over 4. So what happens to 3/4? Flip it. Okay, now again, you should be doing this in your calculator, guys. Okay, but that would equal 12 over 6, which is 2. Okay, if you don't flip the second fraction or if you divide in the wrong order, you're going to get the wrong answer. It's easy to do. All right, I had a lapse in memory also. All right, so there's work that you can show to make sure you don't get it mixed up. It's the first number divided by the second number. Okay, decimals. We got to move on. Quiet. Decimals. Decimals are treated the same way as in you choose the smaller of the two decimals, and please listen to me. We're talking absolute value. Okay, one's positive, one's negative. We're still looking at only the number part. Okay, it's absolute value. So which number is smaller, 5 or 2.5? 2.5. So that's what you pull out. Okay, 2.5. Now you're going to divide the original number divided by the second, or by the factored number. What's 5 divided by 2.5?
Oh, 5, 2. 1, 2.
5 divided by 2.5 is 2. 2.5 divided by 2.5 is 1Q. Technically, did I need to write the 1? Technically, did I need to write the 1? No, I could have just said 2 plus Q, because 1 is understood. All right, so decimals I treat the same way. I factor out the smaller of the two values. 3, we're factoring out negatives. Here's the good thing on your homework tonight. It tells you what number to factor out of the expression. It's specifically going to say factor -4 out of the expression -4p plus 10. All right, so if you pulled out a -4 from the expression, what's -4 divided by -4? Positive 1p. And what is positive 10 divided by -4? What's 10 divided by -4?
Oh, -4.
Not negative.
Oh, wait, no. Wait, I think I
What's positive 10 divided by negative? Guys, use your calculators.
Negative 2.5.
-2.5.
Oh.
-2.5. -2.5. All right, all we're doing is dividing the original number in the expression by the factor number. 10 divided by -4. Okay? So signs are important because if you just said 10 divided by 4, you're going to think it's positive, but it's not because you factored in -4. All right, go ahead and factor out the second expression. I'm going to walk around and check your answers. So we factored out a -5. Okay, so what's -5 divided by -5?
1D.
Just 1D. 1D. What's 30 divided by -5? -6. -6. And can I put it back together?
Yes.
What's -5 times D? -5D. What's -5 times -6?
30.
Positive 30. So again, put together, take it apart, that's factoring, put it back together and to check together again to check your answers. All right, guys, how are we doing? Okay, now we've got example 4, okay? Before we get to this, I'm going to switch over to a sheet of paper real quick. What if I told you that the area of a rectangle is 100 meters squared and that the width of that rectangle is 10 meters, okay? What information do you think you would have to know to be able to solve for the length? I don't know the length. I want to know the length, but I don't know it. What do you think you have to know, Kennedy? Okay, okay. Sarah? No, but what do you have to know? How did you know to do that? What do you have to know? It starts with an F. You got to know the formula. You got to know the formula. How do you find the area of a rectangle? A equals length times width. Okay? So area equals, I'm going to change the color here. Area equals length times width. So what you're telling me is that some number times 10 is going to equal 100. So what is the only value that can make this true? 10. Okay? Let me change it up now. Hold on.
To the second power, though.
Oh, that's just squared because it's surface area. You don't have to worry. The exponent does not, you're just squaring the unit. You're squaring the unit, okay? Because 10 times 10 is 100. So if I know the width, and I know that the formula says length times width, what number do I multiply by the width to get me to 100? It's 10. All right, let's do another one, okay? This is really important so we can actually do, example 4. All right, so now my area is, let's say 80 feet squared. And my length is 20 feet. What's the width?
40 feet. Nope. 60 feet. 60
Okay.
20.
Area equals length times width.
Oh, yeah, 4.
So what number would I multiply by 20 to give me 80?
4.
4. W equals 4 feet. So you guys all understand that I am multiplying length times width to get to my total area. Right? You guys got that? Okay. You say you got it. So now let's look at it with some algebra. All right. The width of a rectangle is 6 feet. The area is 6W plus 360. What is the length? Okay, so here's how it breaks down. The width is 6. The area, big A, is 6W plus 30. Okay, well, you just told me that to find area, I need to multiply length times width, right? Length times width?
I thought 360.
Oh, I'm sorry. I wrote the wrong number. 360. Okay. So if it's length times width, that means I need to multiply 6 by something to get me to my final area of 6W plus 360. Okay. Just like we figured out, okay, if my area is 100 and my width is 10, it's 10 times 10. What would I have to multiply 6 by to get me to 6W? 6 times 6 is 36.
60.
6 times what is 6?
60 from 1.
Thank you. It's 1. It's 1. It's 1.
Oh, it's 1 W.
6, yes.
1 W. 60.
Hold on. Don't get ahead of me.
Oh.
Okay. All right, guys, you're killing me. All right, let me explain it. Okay. 6 times what is 6? 1 W, because I got to get to 6W. Okay. So it's 1 W. And 6 times what gives me 360?
60. Positive.
60.
So, according to this, what is my length?
1
W
plus
plus
yeah,
60.
W plus 60.
See how we did that?
It doesn't go before the
Okay, he said, doesn't the 1 go before the W?
Don't matter.
It don't matter.
Doesn't matter. Because the 1 is understood. I can write it or I cannot write it. It doesn't mean that it's not there. It's understood. Okay? Now, do you think you're ready for example 4?
Let's go. I thought that was example 4.
Nope. That's not example 4. This is example 4. Okay? You guys can do this. I believe in you. A rectangular landing platform for a rocket is 60 yards wide and has an area of 60x plus 3,600 square yards. Write an expression that represents the perimeter of the platform.
Okay, I got this.
Okay, so what is the formula for, okay, let's start with what we've already been talking about. What's the formula for area? A equals L times W. But that is not what it asks us to solve for. What's the formula for the perimeter of a rectangle?
2 times L plus 2 times
Yeah, 2 plus 2.
All right, 2L plus 2W. So if I don't know the perimeter, that's the variable. What else do I have to figure out? I have to figure out what the length is before I can find the perimeter.
Oh my gosh.
You see that? Okay, so if you know the width equals 60, and I am going to multiply that by something, length times width, to give me my total area of 60x plus 3,600. You tell me what the length is. Go ahead and just write it on your papers. 60 times what gives me 60x? 1x. 60 times what gives me 3,600? 60. Okay, so now I can establish that the width is 60, and what is my length?
1x plus 60.
X plus 60. Okay,
Or x plus 60.
what now?
No.
No, it's not. Well, hold on.
Basically.
Maybe.
Yes.
Because like if the length is 60, it's
No, because what does x equal? What if x equals 2? Then it's 62. Okay? What if x equaled 5? Then it's 65. So because it's got the x there, I don't know what x equals, so I can't actually solve it. All right, but that's a really good thought. All right, now I can plug it into perimeter. Perimeter equals 2 times the length, and I said the length is what? What is my length?
1x plus
X plus 60, or 1x, plus 2 times the width. All right, go ahead and evaluate. That looks like distributed property. All right, go ahead and evaluate. It's been a long day. 2x, oh goodness, the bell might ring, plus 120 plus 12. Is this my final answer?
No,
No, wait, it's 2x
P.
plus
it's 132. 2x times.
2x plus
Yes.
132.
Let's go.
Take it, baby. Let's go.
All right. Okay, guys, if you understand that, that's everything you need to know for Chapter 3, Section 3.4.
Okay.
All right, we're done with Chapter 3.
Chapter